In this question, you're asked to integrate tan square x, cot square x and sin square x by 2. So let us do each of this. So first, if you think about integration of tan square x, so there is no direct formula to integrate tan square x. But, so I can write tan square x as, we have the identity secant square x minus tan square x is equal to 1 always. So tan square x can be written as secant square x minus 1. So this is a trigonometric identity. So now I can separate this into integration of secant square x dx minus integration of just 1 dx is dx. So secant square x can be integrated directly. So the integration of secant square x is tan x minus integration of dx is x plus finally some arbitrary constant. And similarly, if you want to integrate cot square x, so cot square x can be written as integration of cosecant square x minus 1 dx. And if you do the same separation here, integration of cosecant square x is minus cot x minus dx's integration is minus x plus c. So that's the integration of cot square x. And next, if you want to integrate sin square x by 2. So here also there is no direct formula to integrate sin square x by 2. So we'll try to manipulate this using some trigonometric identities. So secant sin square x by 2 can be written as 1 minus cos x by 2. Because 1 minus cos x is 2 sin square x by 2 is sin square x by 2. That is equal to 1 by 2 times 1 minus cos x dx, integration is x, and minus integration of cos x is sin x. So half of x minus sin x plus an integration constant finally. So this is the integration of sin square x by 2.